actually been a supporter of the MLC for many years, and actually a good friend of mine for many years as well. So I'm really pleased that he volunteered to do this for us today and share his knowledge. Jeff is currently the Service Growth Director for the new power products at Cummins Sales and Service. So before assuming his current role, Jeff was the General Manager for the Mid and Northern Michigan Service Corporations for Cummins. And his responsibilities included directing the day-to-day operations of shop and field service operations for the engine and the power generation markets, which included the product sales, customer experience, and overall overseeing the health and safety of the entire operation. So Jeff's passion for lean began when he was a continuous improvement and quality leader for Cummins Bridgeway, which was a legacy distributor that was acquired by Cummins in 2014. So from 2010 until the acquisition, Jeff built a top talent continuous improvement group that helped introduce and incorporate lean principles into all of the segments for Cummins. So he's got a lot of experience, and we're glad that he's able to share that today. So without further ado, please welcome Jeff Ferrani.
Hey, thanks, Kim. How's
You're welcome.
Hey, this is actually a really I'm really excited to do this. Kim and folks from the MLC reached out to me a little bit ago, a few months back, and asked if I was interested in doing a coffee chat with the group, and I said absolutely. This is kind of where my roots lie. So when I was part of Bridgeway, we were heavily involved with the MLC. We actually took part in a lot of benchmarking opportunities. In fact, just before the phone call, I was discussing with Andy on how we used to leverage different benchmarking events, and also used to bring leadership from Legacy Bridgeway to those events so that they can kind of get a look and feel of how different organizations operated. And there was a big stigma with continuous improvement quality back then, and honestly, it was like everything was a Six Sigma project within Cummins, and they forced that methodology down to the distributors, and so you couldn't really, they had targets for improvements, but you couldn't do anything other than a Six Sigma project. They're like, well, wait, time out. There's other things that you could do here. And so the MLC was instrumental in helping us help that journey. So hopefully everyone can see my screen. Can I get a thumbs up from the group? I think everyone's on mute. Good. Okay. And I guess, yeah, that'd be the only, I guess that's the only administrative request. Keep yourself on mute, with the exception of if you want to ask a question, just to avoid any noise from folks. So, I'll skip some of my intro, but also if folks could type in the chat, what industry are you coming from, and how many years have you been involved with the MLC? So if you could type that in the chat, that'd be awesome. Well, it looks like we got about 28 folks here on the call. Healthcare, 5 years. Figured there'd be a few. Government, food. These. Manufacturing, and I apologize. I'm gonna try to do something on the fly with the data that you guys are giving me. Automotive. All right. Manufacturing. Awesome. Utility. Education. And hopefully I'm not too much of a typo. Okay, utility. Another one. What's that?
Is it all caps?
It's all lowercase.
All lowercase.
Okay, awesome. 6 years total, 10 years of continuous improvement excuse me, 10 years of continuous improvement experience. Awesome. Okay. Well, I appreciate that. So let me get started. And I like the picture here. As Kim mentioned, I'm part of Cummins Sales and Service, or part of Cummins Inc. This is one of our new hydrogen fuel test cell trucks that we've got floating around. Actually, we've got 4 of them floating around in California. And I was fortunate enough to see that truck last week. So let me get started. So here's today's agenda for this morning's call. Kim's already kind of done a really nice intro for me, so I'm gonna maybe not speak as much to my experience, but I'm gonna get into some root cause investigation tools that I found that were really helpful for myself and for other continuous improvement folks and other leaders, just when you're trying to tackle a project or look at some problems. I also am going to run through some application examples as well. I'm gonna move this just so I don't have that there. Sorry, just want to get my notes. Well, little administrative housekeeping here, and then we'll run through some Q&A. So if folks have any questions, feel free to drop them into the chat. Raise your hand. I can interrupt, and you can interject with on a slide if you prefer, or you could just wait till the end. And then that should be it. Any questions? Or are we good? Okay. Let's see here. And slide, you should be moving. There we go. All right, so this is the group that I'm a part of. It's a new team. It was just, I've actually only been in this role for about 4.5 months now. But we're primarily a North American based team, and my role is to help integrate our battery electric vehicles, our compressed natural gas and hydrogen units into new and existing business markets. We leverage with cross-functional teams, so we work with HSE or we work with operations or sales, primarily so that we're successful in integrating these new products. Cummins for 100 years has been primarily a diesel and power generation based company, so these new products are much different than diesel or octane products. So it kind of requires some additional things to get into. There's me and a few of my team members that work alongside with me. My background is actually in finance, so I'm a Wayne State University alum, both from the business school in 2004 and in 2010, and I actually got my start with Ford Motor Company. So and I think Kim did a really nice job of outlaying what I've done since. So let's get to the content. Okay, so this morning I'm going to talk. So I've got a few different tools that we're going to talk about, and then also I'd like to just show where you can apply these tools within the DMAIC project approach. So there's if anyone has had the opportunity to apply one of these tools in a different area or just in a different type setting, yeah, it'd be great to hear. So we're going to cover Pareto's and scatter plot diagrams, talk a little bit about the 5 whys and 5 hows, as well as a fault tree analysis. The two are really aligned in terms of how they can go together. Give another example of another diagram or another tool, which is a fishbone diagram. So it's kind of like a cause and effect tool. And then we'll talk a little bit about FMEAs. FMEAs is something that you could spend probably an entire day discussing. So it's going to be tough to cover in an hour, but I hope I can give you a good flavor and show how we've applied it within Cummins with some of our projects and the like. So any questions? All right, don't see any hands raised, so let's get to it. Okay, so Pareto analysis. So Paretos are pretty helpful tools. You can apply them to pretty much almost any problem or project. It's a first level investigation tool that can be used when investigating a specific situation. It's based really on the 80% of consequences come from 20% of the problem, or the 20% of the causes. So the whole 80-20 rule. It also, again, it also asserts an unequal relationship between inputs and outputs. So what really, you may not have equally weighted variables that you're evaluating. And then, of course, it identifies problem areas or tasks that will have the biggest payoff. So here are a couple of examples of Paretos. So they're relatively easy to complete. You can do them in either Excel, or you can look online and pull a Pareto template, or you can use Minitab. There's many ways you can do it. So here's a quick example of a couple of Pareto charts. Here's one looking specifically at root causes. This is a billing efficiency issue. So looking at root causes in terms of where things went awry. So communication, troubleshooting process, communication external. And then here's actually, hopefully I don't know if I can, maybe I could share it in the chat. I actually did a quick Pareto of just the question I asked the group when we got started, which is basically what's the industry that folks are joining us from, as well as the number of years with the MLC. And let's see, can I just drop that in the chat? Maybe. Let me see here. There we go. So just based on what the group shared, here's a quick Pareto as to where some of the folks are joining us from. Apologies because it was kind of quick in terms of what I was trying to capture, but you can get the idea. You can really create a Pareto over different things that you might be measuring at home or a project. But it's pretty easy tool, and it's also really helpful because what it basically is potentially telling you. You need to go look at missing screws, or you need to, your top two causes of a defect are either missing screws or missing clips, or you got a communication issue, or you're going to probably get better input from folks in the education or manufacturing area. But it just helps you identify where one of those problems might be. Okay. Next, I'm going to talk about scatter plot. Any questions on this, or are we good? All right, I want to try to keep an eye on time because next, here's another example. This is a Pareto basically just in a different way, but here's safety data, and there you can look at incident occurrence, so housekeeping, slips, trips, and falls. Here's some find it, fix it information. So we've got more of a proactive approach with what we're trying to do with health and safety at Cummins right now. So we're measuring recordables and the number of incidents that we have, but we're also trying to tag and record so find it, fix it's a kind of a proactive approach of see a failure, see a problem with safety, address it, submit it, and let's compute where some opportunities are coming from. That's just another view of a Pareto right there. Okay, scatter plot diagrams. So scatter plot, also called a rifle shot. This is a tool that'll take data, take dots to represent values for two different numeric variables. The position of each dot and on the horizontal axis indicates values for an individual data point. So the scatter plots are really helpful to observe relationships that may exist between variables. So I've got a couple of things here. You've got you can see a positive correlation, or you could have a chart that's going in a negative correlation, or you could potentially have absolutely no correlation when you're looking at variables. So correlation does not necessarily mean causation. It just simply means that as the vertical axis decreases, the horizontal is going to increase. Some people think that negative correlation is bad, but it really has nothing to do with being good or bad. It has to do whether or not there's a positive or negative correlation. And if there's no pattern of evidence with a trend in either direction, you're going to see that the two pieces of data have no correlation with each other. In the examples here, here's scatter plots based on braking speed. So the amount of speed times the amount of speed that a vehicle is traveling, along with the amount of distance that's going to be needed in order to make that vehicle stop. And then here's another example of a scatter plot looking at sales of ice cream with the temperature, as the temperature rises, what does sales of ice cream do? So some other scatter plots that I've done in the past, or I've seen, so length of time a work order is opened along with billing efficiency, and then looking at the number of technicians on a job and their time along with labor recovery. NPS scores, so Net Promoter Score, which is a customer satisfaction measure, looking at the number of times that a customer has been contacted along with updates or repairs, and looking at their response scores. So, okay. 5 whys and a fault tree analysis. So 5 whys is basically an input root tool. 5 whys and hows. It's a root tool that can be applied into a fault tree. So and here's an example of a fault tree sheet that pretty much almost follows the entire DMAIC approach. You can even list you could even list out controls here and use an FTA to potentially be an A3. But the 5 whys and 5 hows is a technique of questioning designed to drill down on the details of a problem, and it's looking at trying to peel away layers of the symptoms. So it's trying to back out the onion. It's the toddler approach of, why are we doing this, or why do I need to get dressed, or if you follow that similar logic and lineage, it's really helpful with health and safety. So we do, with incident investigations, we apply a 5 why approach. But just an idea, just from the where this concept was originated from, Sakichi Toyota, who stated, by repeating why 5 times, the nature of the problem will become clear. So, and the solution becomes clear. Excuse me. So. And you'll also note too with these slides, I'm going to make sure that the group has these, but I've included some links going directly to the ASQ, which is excuse me, I'm drawing a blank. It's a quality site. I don't want to say association. Help me out here, anyone. Can be used to build prediction models.
American Society of Quality.
Thank you. Drawing a blank. Yes. So there's more opportunity to read up on some of these different tools. Here's another 5 why approach. So this is looking at this is a way that we've done looking at a customer with low miles per gallon for a fuel economy project. So we describe the problem, which is fuel economy lower than desired. Root issue that we're going to investigate is low miles per gallon. And then there's a summary of the failure, which basically outlines some of our findings. But you basically just start going down the track, or going down each segment for opportunities in which that a problem may arise. So, with a truck, it could be vehicle specifications with the way it was set up. It could be the driver, or it could be maintenance related matters that of how the truck itself is maintained. So here are some different areas in which that we would want to look at. Here's some of the characteristics that we're concerned with. So aerodynamic aids being one versus. So they were comparing 2 different trucks. Their Volvos were getting better fuel economy than their Freightliners. So, and then they had different transmissions. So different transmissions on the vehicles. So they were comparing an Eaton transmission with an Allison. So you end up with have some variables here that are being considered, where you're going to gather your data. You assign a person somebody that can help with gathering that information, when they intend to get that feedback back to you, and then of course what were their investigation results. So that's kind of how an FTA can be applied. How an FTA can be applied specifically toward a problem and or a project. This was a project to help a customer with its fuel economy, but I think I've got another example loaded in here. Yeah, I do. Here's a 5 why approach, but again, it's outlaid similar to an FTA. It's just so this is looking at distributor warranty and or free customer service. So distributor warranty is basically it's our warranty and or policy. So policy isn't exactly warranty, but it's goodwill that we may give customers for a reason or a reason that their product itself has failed. And so this is a 5Y FTA approach, looking into why distributor warranty or free customer service may be provided to a customer. And here's the different track that it went down. So if a customer is issued distributor warranty on a work order, here's some of the reasons why. So oversight in the repair process, bad workmanship, completed the wrong repair. It happens. Incorrect coding. So we may have actually built it improperly. So, and again, going down the path of asking why. These are the findings and the investigation, and what potential course of action may we need to investigate things further. So, okay. Let's see. Where am I on time here? I'm at 8:52. I'd like to be able to open up for Q&A, but I got a couple more things to discuss here. Okay, fishbones. Fishbone diagram. So this is another tool for structured brainstorming. So it's meant for improvement teams to come up with potential root causes for an undesirable effect. I'm sure you've probably read or heard, but it's looking at using the 6 M's or the 6 P's approach. So usually causes are identified and grouped within major categories. So this is a pretty good quick tool that working with a group and looking at a problem, you can look at the 6 different elements of that problem to go and investigate things further. So the 6 M's, man or mind power, or method being the process, the machines, so or the program that they're using, or the machines used to produce the product, materials. So if they're manufacturing something, or whether it be the input or it be the output, measurements and or policies that may be involved, and then Mother Nature and or place. Just good real-time example. We're trying to get battery electric vehicles off the ground, and one of the requirements is a quarantine thing that we need for lithium-ion batteries. Interestingly, the coverage has to be the area has to be temperature controlled as well as covered. And so in a place like Las Vegas, you can't throw a battery pack and throw it in a Connex container. We need to make sure that stays less than 140 degrees. A Connex container with no heat in the middle of the desert, probably not a good thing. So that's just an example of how a Mother Nature constraint on a problem. So this is an example of a fishbone. This was our Glen Burnie location out in Maryland that had done a fishbone looking at efficiency. And so you see the different inputs or the different M's that are here. And then of course the common XAs, XBs, and XCs, so the common elements that existed. And leadership was by far the most common attribute that was identified when it came to looking at in-shop efficiency. So potentially holding folks accountable and staying to task in the standard. So FMEA. Okay, FMEA is like I mentioned, this could be a half-day module, but failure modes and effects analysis, this is a really helpful, awesome tool to use. This is probably a process FMEA is probably one of my favorite tools to use, because it's detailed. It pretty much points where you really want to go, or what you really want to go and investigate. So I really like using FMEAs. I'm most familiar with using a process FMEA. But there are some different types of FMEAs that are out there. So it's a structured approach to identify ways in which product fails. You can estimate the risk associated with specific causes. You can then prioritize those risks, and then you evaluate, design evaluation plan or a control plan, all using an FMEA. So the 4 different types of FMEAs, you can look, there's a FFMEA, which is looking at how parts or an asset can break. There's design, so DFMEA, so investigates what can go wrong with equipment as it's being designed. There's your PFMEA, so this is with operating an asset or maintaining. PFMEAs are really helpful for maintenance procedures and safety. So or lockout, tagout. So when designing equipment or designing an HSE process, and then of course FMECA, which is looking at a potential failure and the impact that it may have. So here are a couple of examples of FMEAs. So one of which, this is looking at an HR recruiting process, and we actually have a tool, and I'm going to incorporate it into the appendix here. But we had a really cool tool that would allow you to do a 50K process map to a 10K process map that you could drop to a CNE, and then eventually upload items from your CNE breakpoint to incorporate into an FMEA. This is an example of one of those, and I'm going to actually upload that template into the PowerPoint before that could be shared with all of you. Kim's really familiar with it, but it's what it's helpful to do is taking key process steps and then looking. So this particular FMEA was looking at our HR recruiting process and problems that we had with the length of time that it was taking getting candidates, for potential candidates, from a requisition being open to getting those candidates hired and brought on. We had a pretty significant length of time, and I guarantee if we did that project today, the times would probably be worse, just based on how hard it is to find folks. But anyway, this particular example of an FMEA is, you see the different process steps that we could potentially look at. Here's what are some of the failure modes that can go wrong with the process step? What's the effect on it? Now, the most important thing with an FMEA is the control, is the identification of how severe the issue could be, the occurrence in terms of how likely or how often it may have, and then what's your main, what the other is your ability to detect it. Okay, so if something were to go wrong and it occurred, what kind of control measures do you have? How easy would it be to detect that particular failure? And then the combination of those 3 numbers gives you what's called an RPN, or a risk priority number. That risk priority number, if then sorted, kind of gives you your roadmap as to, okay, this might be the potential areas or the potential process steps that need to be investigated. So with this example, we broke down. So if I'd say probably the first 4 or 5 things here, the RPM where it's greater than 100, we use the breakpoint of 100. So actions that we recommended, and then we also then came back with what were the actions that we took. Ultimately, we ended up bringing in a recruiter. There was, at this time, we didn't have a dedicated recruiter that was helpful, and by bringing in a dedicated recruiter to assist in recruit and locating candidates, we're able to improve our cycle time of requisitions to new hires. So, and then again, after we made the change, after we made some action, what did our RPN score then drop to? So here's where we were at before we took action, and then here's our final FMEA, which basically is, did we make an improvement? Let's see here. So here's another example of a process FMEA. This is looking at, from a safety perspective, looking at vehicle driving related incidents. And I don't have specific actions on this, but this was just when we were looking at a safety issue. So we were having a high number of vehicle incidents with our field service truck, with our field service technicians, as well as other employees that drive for the business. we were experiencing a high number of vehicle driving related incidents. And so what we did is we assembled a group to basically to go through and investigate what are some of the reasons why. So some of it, so we could have applied a Fishbone with this analysis, but instead we took the approach of an FMEA. But you could see some of the different inputs. So it could be the driver, the surroundings, environment. So those were pretty much the three main inputs. But then what potential failures could happen with the environment and or with the driver. So snow and ice. So we'll have a lot of issues in Michigan with that in the wintertime. Along with some course of action that we recommended. Again, the same severity, occurrence, detection, calculate an RPN, and you can notice that I don't have some specific actions that were taken, so no change in the RPN in here. But I just wanted to give folks a flavor for how an FMEA can be applied.
Jeff, we've got, it looks like a question.
What do we got?
Hey, Jeff, this is Sanket here. Really nice content, great presentation. Thank you. I have a question. You in the previous slide, you mentioned we could have applied a Fishbone, but we chose to go with FMEA. My question is around that, like, how do you make those determination? What type of thought process? Do you have a framework to determine I want to choose this RCA method versus something else?
So yes, we do. And you don't want to and to use the analogy, you don't want to use a hammer to kill a fly. Or every problem doesn't require a hammer. So we actually have I don't have one in this PowerPoint, but we've got a track, kind of a project tracker that outlines out the DMAIC approach. And what it also does is it gives some idea, it gives a belt some ideas as to which tool that they should potentially use based on the problem that they're facing. So it'll give some recommendation based on past practices, and it's kind of a culmination of what MBBs have used with or what they've seen on projects for particular problems. So that's just one way to do it. Or that's just what we have as trying to help our belts use one particular tool or another. And then also too, it also depends on the I guess I'm giving the MBB answer. It depends. It also certain either black belts or MBBs may also have a tool preference, so that also can drive how things are, what tools are applied. Not saying I had any personal bias. Does that help? Does that answer your question?
Yeah. Thank you.
Okay.
Appreciate it.
My pleasure. So I'm actually at that point. I tried to, I wanted to probably have about 30 to 35 minutes worth of content. We're there. I'm just going to add in here. So I do have an appendix. I'm going to make a couple of modifications. So I recognize that there could be folks on this call that don't have access to either Minitab. Minitab is absolutely awesome. It's got an analysis pack that, like, I mean, it's really, really helpful. I mean, you don't have to be a stats expert to leverage it, but it'll really help you organize data and also help you with help you with some of the statistics that you might get into. But what I have in here is I've got some templates that I'm going to drop in here and share with the group. I'll also share. I don't think it's in there now, but there's a document that goes from 50K to 10K to a CNE to a FMEA. So basically, it's just kind of it's a series of macros that can help with setting you up for using all those different tools. So, okay, let's go back to here, which is Q&A.
Hi, Jeff. Great job. One, I just want to make a comment about that tool you were just referring to. I have used that, and it's fantastic because it's set up that, like you said, when you go through your 5K and your 50K, it will just populate into, the next tool that you need to use to keep, dwindling down basically to where you need to be and the issues for root cause. So fantastic tool. I haven't seen that anywhere else besides Cummins, and it's used quite a bit. It was nice that you touched on that one too.
Thanks, Kim. Actually, I'm going to, okay, we're in the Q&A period, so what I'm going to do is I'm going to hop out of presentation mode, and I'm actually going to drag that particular tool over to my screen, so folks can kind of get a flavor of what it is that you and I are both talking about here. So again, it's a macro enabled tool. It's a simple Excel workbook, but it gives you the ability. Here are your inputs that you would identify for a 50K process map, and then here's a more detailed or a 10K level view process map. So identifying your process specifically, as well as your inputs and outputs. You'll notice that once you do this transfer to C&E, it'll give you the ability to go through and do a C&E for your inputs, for your process steps and inputs. And then that could actually then populate your FMEA. So all within one tool. And then there's that FMEA scale that I was referring to. And it gives you some instructions, even better. It's been about a minute since I've used this, but either way, very, 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 very helpful tool. So what else do we have? Okay, actually, let's go up through the chat. Sorry, there's a Mike. Michael, do you go by Mike? If you're on mute, feel free to come out. Let's. I noticed you had a question regarding correlation.
Yep, go by Michael. Thank you.
Michael?
So, yeah, the question was, can correlation be used to build prediction models or forecasting models?
Yeah. Can you elaborate a little bit further? I'm gonna say yes, but what kind of an example?
So some of the graph, the scatter plot examples that you had there showed, you were talking about positive correlation and negative correlation. The more this increases, the more that increases. Some were kind of like a cloud of dots, maybe no correlation or no strong correlation, and some were literally like a straight line. Like if you held up a fat crayon, you wouldn't be able to see any of the dots, right?
Yeah.
And so the question there is, can you use the behavior of those variable pairs to predict what one variable might be given a provided value for the other?
Yes, you could. And the one thing that you want to caution on, the stats test specifically, I'm not sure which one that you would run, but you want to make sure that you've got a strong p a less than 0.05 p value to make sure that the two pieces of data that you're measuring are in fact directly there's good confidence that the two are related. So yeah, you could use it as a predicting factor. So in fact, that's one of the tools of, say, maybe a regression type tool, where you come up with your predictive formula, to where you're dropping in a few variables, and then you can almost potentially pinpoint, if you've got good correlation between the two, you could potentially pinpoint where the output would be based on your input variables. Is that helpful?
It's very helpful. Thank you.
Okay, sorry. It's been, that was a good question. I haven't had my good stats wake up in a bit, but yeah, no, there's actually there's a really, I don't know if I actually have that tool, or if I have that book with me. I'll share it, but I actually had a really good really good helpful tool. It was a book that kind of worked alongside with Minitab and helped with the stats, helped with some of the stats portion of using Minitab and tools. but I don't have it in front of me. So, but I'll share that book with folks, because that would be a perfect question to apply into that quick reference. Okay, let's see. Is this an add-in tool with Excel, or is this a separate tool that has to be purchased? Carl, what do you mean is the add-in tool? That Excel workbook, or is it Carrie? I'm sorry.
It's okay. That's okay. So, no, you said it was in Excel, that tool, right? Or Minitab? I need a little bit of clarification on where that is.
Minitab itself is a statistics tool. Tabulo is another. They're not actually add-ins for Excel. They're actually separate programs. But Excel itself does have some statistics. It does have some additional add-in capability. That can help with some stats related items, and it's pretty helpful. But I would if you have the ability to hop into Minitab or get Minitab, that's also really good.
Okay, because we currently use the Power Platform, Power BI,
and
Tableau, and stuff. So okay, I was going to look in there. So okay, thank you.
Yeah. The Power BI, and honestly, I think I very rarely in my role now do I really ever go and use Minitab. I'm pretty much fully functional in Power BI and or Excel. So okay, let's see. Differences between 5Y and FTA. Okay, yes, elaborate on some of those differences. I actually did. So I did include a template just for a 5Y. You don't necessarily need to do an FTA for all of your for a 5Y exercise. A 5Y it can be applied both in. I mean, you see, I showed how it was done within the concept of an FTA, but a 5Y could just be done. It could be done as while you're out on a Gemba walk, walking a floor, or talking with a group of team members. Safety is one area as well. So in the event of a recordable incident, like using the 5Y approach as to why somebody was injured. I think that's some of the difference between. They're both investigatory tools. They're not necessarily going to give you a smoking gun on a stats level basis, or you'd have to use a 5Y or an FTA in conjunction with, say, a Pareto or an individual or moving range control chart. But what it does give you is it gives you the opportunity to identify some root cause items. So does that help, Jason? Or do you want me to go a little further? Okay. Sorry, great examples. My pleasure, Jason. What else is up there in the chat? I'm sorry. Good examples.
I think that's it. I think you've covered them, unless anyone has anything else they would like to ask.
I have one more question, Jeff. Just curious about on this slide, the judgment column at the end. Can you talk a little bit about how do you arrive at those judgments?
So the judgment itself. So there's a couple of additional things with the results. So no problem being uncertain are one of the causes. So where in which there was no problem itself found. So I'm going to follow this 5Y across. Honest oversight in the repair process. So either technician inexperience, or was that tech working too quick? Inadequate training for the technician. So this is not totally uncommon. Meeting efficiency goals on the work order. Okay. But then you got, let's see, the technician class. So you could have a particular type of technician working on a type of problem that they're not as familiar with. And then the investigation result, okay, distributor warranty by technician class. The investigation result, Tech class is not significant. It's mostly A's. Okay. All right. So the no problem here that's being applied or this judgment. So there's much more going on in with this problem. So the example that on the investigation result is that a technician's class is not significant in terms of in terms of distributor warranty being issued. So logic would say something like you're less experienced, your technicians from that are either power gen related or they're engine technicians. Is there something going on specifically where in which that we're having to issue more distributor warranty just based on their classification? And what this is saying is that there is no problem specifically just with classification. Could there be some relationship? Absolutely, but you'd have to investigate that further. That in and of itself is just not enough to warrant further investigation, just on the merits of that alone. And that's basically, so the investigation result in with the judgment is what it's telling you. So with the circle, the no problem, yeah, we're for sure confident that that investigation result is not playing a factor into the distributor warranty. Now, where it says uncertain, so again, this is techs working too fast, they meet their efficiency goals, distributor warranty just based on technician efficiency. Efficiency can be masked, and it's difficult to correlate. So uncertain. That investigation result is that's exactly correct. So based on the path of what they did and what they looked at with in the investigation, they're correct. Efficiency can be masked, and it could be difficult to just taking technician efficiency alone and comparing it against the distributor warranty spend. So I would argue that you could have either used no problem and or uncertain. Either of those would have been applicable. But then where you see these X's, these are the areas that are definitely one of the causes. These are things that you would want to investigate further, and look to potentially problem solve around. So I see 20% of distributor warranty may be avoided with a quality assurance check. Possibly. So a final check of a vehicle before it left a bay, or final check of a vehicle or a product out at a customer site. Yeah, depending on what the root cause of the distributor warranty was, if we were able to reduce the distributor warranty expense by 20%, and it was attributed to items that would be covered under a quality check, that's definitely a good area to look in. And these are administrative errors. So you got distributor warranty that was coded in error. Again, one of the causes that's contributing to the higher than expected expense in distributor warranty. Is that long way to get there? Hopefully that was good.
Yeah. It was. Thank you.
You get the logic though.
Yeah, that's what I was trying to understand. Thank you.
Yes, cool, good. Okay. All right. Let's see here. So got about 10 minutes. Anything else?
So no other questions? Jeff, thank you so very much for hosting today. We really appreciate all your knowledge and sharing with the group. We had a lot of great questions. Wonderful chat this morning. So thank you so much, and I hope everyone enjoys the rest of their day.
My pleasure. Thanks, Kim. Thanks, group. Really appreciated the time. And if you have any questions, I'll make sure. Hopefully, I'll have my email or phone that you can reach out to me directly. Thanks so much.
Very good. Great. Thanks. Bye, everyone.
Great job. Thank you.